So students, in this video I am going to explain about the sodium hydroxide. Sodium hydroxide formula is NaOH and its common name is caustic soda. Now caustic word means anything which corrodes, it causes corrosion. You must be knowing uh, we use soaps, we use detergents for cleaning action, and particularly during the winters, you must have noticed we have to use some, substances like skin conditioners or oil to keep our smooth skin, because during the winters, the oil glands present in the skin they do not produce the oil, and as a result, the skin becomes, oilless or less oil is there. So, entire cleaning is done, and rather more cleaning, and the outer layer of the skin is lost by the soap. It corrodes. Now, same case is with the detergents. So, detergents and all the cleaning agents, they are somehow mixed with the sodium hydroxide in less amount or more amount depending on the quality of the cleaning agent. Now, preparation. So, preparation, it is prepared by Chlor alkali process. Preparation by Chlor alkali process. Chlor, the word chlor stands for chlorine, and alkali means any basic material which is water soluble is called as alkali. So sodium hydroxide, potassium hydroxide, or any base which is water soluble is called as alkali conventionally, but it is not necessarily. Generally, we use alkali for any basic substance. We don't categorize. Just I am saying for the name's sake, what is alkali? Now, in chloralkali process, brine, it is aqueous NaCl. So, aqueous NaCl, it is electrolyzed. Current is passed. This is brine. Sodium chloride solution is called as brine. On passing current or electrolysis, there is formation of NaOH aqueous, hydrogen gas is produced, and chlorine gas is also produced. Now this chlorine gas is produced at anode. It is produced at anode, and it is NaOH and hydrogen, it is at the cathode. Now this is very significant part. Now how the reaction proceeds? Actually, first you have to go through the basics. So NaCl aqueous, it dissociates. It, from the junior classes, there is the ionization, there is the dissociation. So there is formation of sodium and chloride ion. Now we are passing the current. So current is passed by the electrodes, and positive electrode is called as anode. So at anode is positive. So at anode there is always oxidation. At anode there is always oxidation. Oxidation is loss of electrons. So here the chloride ions which are negatively charged, they are attracted toward the anode, and there is formation of chlorine gas, and 2 electrons are released. We have to balance. So here we write down 2. Now at cathode is negative in electrolytic cell. Electrolytic cell means the vessel. It is a vessel. Generally, the electrolytic vessels are made up of such materials which are bad conductors. Vessel is bad conductor because if it is conductor, so there will be the short circuiting or it will blow off. So we use like stone, granite, plastic, slate, any non-conducting material is taken. So this negative. So sodium ions are attracted toward the negative. Now the sodium ions, they gain the electron. gain of electron is reduction. So there is version of sodium solid. So at anode there is oxidation loss of electrons, cathode there is reduction gain of electrons. So there is version of sodium solid. Now the solution has the aqueous nature, solution has water. So in this the sodium produced, it will react with water. So it is at the cathode. So there will be reaction, very slow reaction, because it takes place at the atomic level. All the reactions take place at the atomic or ionic level only. You know, molecules cannot take part in the reaction. Molecules has to be converted into either atoms or ions. So one atom is produced here, so it will react. So it keeps. It is nothing that large amount of sodium is deposited, then the reaction begins. Reaction. No, reaction takes place step by step. It's very complex process. So there is the sodium hydroxide, aqueous, and hydrogen gas is produced. So this is around the cathode. So this NaOH aqueous, it is concentrated. It is concentrated by boiling to get the lye. Paste of NaOH is called a lye. Then it is further processed to get the NaOH solid. Further processing there to get the NaOH solid. Now coming to properties. So sodium hydroxide is white colored solid. It is water soluble. Its aqueous solution is very strong base, because I have shared you about the strong base, weak base. So sodium hydroxide, potassium hydroxide, they are very strong base. So similarly NaOH, because NaOH dissociates completely and there is version of very highest amount of hydroxyl ions. Now it is corrosive in action. It corrodes. I have started in the beginning. It causes corrosion, so it has corrosive action. And basic reactions, it turns litmus. This litmus, bases turns red, litmus blue. So this is. Now coming to the uses of the NaOH. Now NaOH is used, as I have said in the beginning, starting of the video, in the preparation of cleaning agents, soaps, washing soaps, toilet soaps. They are prepared using the NaOH is used as a starting material. Others are there also. Then cleaning agents, many cleaning agents, washing dishwashers and so many things, hand wash, many more. Then there is the processing of fibers. Fibers are processed using the sodium hydroxide. Then in the preparation of artificial silk or rayon, in the preparation of paper also. Paper is prepared by this also. Now one very important point about sodium hydroxide, that sodium hydroxide has very important property to absorb the moisture from outside, and this property is called as hygroscopic. Hygroscopic nature. Hygroscopic nature means it absorbs moisture from outside and it becomes just runny liquid. Now it is in laboratory, you see sodium hydroxide, we keep very close, but the container becomes liquid, it becomes runny, just it absorbs moisture from the outside, and this property of any substance is called as hygroscopic. Hygroscopic, hygroscopic property.